Hello everyone, welcome to week 2 live session for the NPTEL course Blockchain and its applications. So for those who are joining the first time, these live sessions are meant to be a sort of interactive and problem solving session. So if you have any doubts or queries pertaining to the week's lecture, you can post the questions in the chat box or raise your hands and ask the questions yourself. Okay, so uh, any queries, if you if you have, you can raise your hands and I'll call out your names and we can discuss those. Mahendra has asked, can we have the link for the previous session recording? Yes, I guess the links I guess are shared. Um, Maybe 1 second. I'll just see whether it's shared on the course website.
ये कॉलम बोर्ड यूज करती हो कॉलम बोर्ड
Mahendra, if you go to the course website CS15, in the left-hand side column you will see week 0, week 1, week 2, week 3 like that. And at the bottom you will see download videos and then problem solving session Jan 2024. So if you click on that, there will be a link. If you recording link, you should click on that. It will open a Google Sheet, and there for every week it will be present the YouTube link, and also the notes folder. Whatever I have shared, I have written it down during the discussion, right? So that would be shared. I am just sharing the link to over here. In the Google chat box, I've shared a spreadsheet link also. Okay. Samiksha, you have raised your hand. Do you have any query?
Yes, sir. Hello, sir.
Yeah.
Can you explain RSA encryption and decryption?
Right. So the basic, not going into the mathematical details. Okay. So that's not like fully required. The general idea of these public and private keys. That's what you mean, right?
Okay.
Or do you want the mathematical details to? Hello.
Hello.
Yeah. So your doubt is like how does RSA work, right? The public and private key.
Hello.
1 second. Hello, am I audible?
Yes, yes.
Yeah. So your question is RSA, public and private key, how they work together,
Yes, sir.
right? So basically, RSA is part of these cryptographic primitives called public key cryptographics. Public key uh, like that. So usually they call it PKS or something PKCS, public key cryptographic primitives. So first, before understanding, getting to know what RSA is and how it works, I'll just mute you since right. So before understanding what RSA is like, how is it designed, as in the public and private key, we should first understand why RSA was required in the first place, right? So before RSA, you would remember that I guess in week 1, you would have learnt about anything like AES encryption or something. Did you learn?
Yes, sir. Yes, sir.
Right, so AES encryption, so advanced encryption standard. Right? So AES usually it will have like an encrypt function, right? It will have an encrypt function, and to it, as you will pass the input, and you will also pass a key K, and this K should be a secret, right? And this will provide you the encrypted output. And when you pass the encrypted output to the decryption function, secret key, it will give you back the input, right? Now the assumption is this secret key should be known both to the sender and the receiver, right? So this the assumption, both the sender and receiver should know the secret key, and for proper confidentiality. So confidentiality as in only the sender and receiver should know the messages, means only they should know the secret key. So your entire the feature of AES, the protection or the confidentiality, whatever AES offers, will only be uh, correct, or it will hold that confidentiality will hold, right? So the confidentiality guarantees of AES will hold only if the this condition is satisfied, that is the sender and receiver are the only ones only ones knowing this secret key case, right? But in a real world system, you cannot be sure of this guarantee, this condition, right? Whether it will be satisfied or not. Say, if they are close by, they can communicate the secret key. So, via like they can write it on a paper and pass it or something like that. But assume you want to send some file over the internet, and the sender is in one continent and the receiver is in another continent. Now, how do you send this secret key K? First of all, how will you determine the secret key K? That's a big issue, right? You can tell like, okay, I
Yes,
can
sir.
have another secret key and then use that to send this secret key, but who will determine that secret key? So it's like a chicken and egg problem, right? Hen and egg problem. So to overcome this problem, they came up with this cryptographic primitives called RSA. In RSA, what it is basically, it all boils down to set of mathematical functions based on prime numbers and all those things. Okay, so if you are interested in the mathematical details of these cryptographic primitives, I'd recommend you this book called Cryptography and Network Security by William Stallings. So in this book, they sort of go in depth, as in like the basic understanding of all these mathematical functions. They sort of give an intro to these mathematical functions like prime numbers and all those things. They give like a background, and also then they explain these cryptographic primitives. But as far as this lecture is concerned, I guess you need not dwell so much into the mathematical details. So, just giving an overview of RSA, the key point in RSA is instead of relying on just one secret key, they don't rely on just one secret key. Instead, what they do, they take a pair of keys, and the pair they take it as public and private. And what they do is one of these keys will be made public. It is known to everyone. And this over here should be maintained a secret, known only to the user. So, for example, Akshay is having a pair of key, is having this RSA key, means in that one will be a public key which is made public and known to everyone as in friends of Akshay, and the private part of this key, the private key, would be known only to Akshay, right? And now the cool thing with RSA is they can use when we tell so in AES there is this key generation and all these things, like how will the secret key, it will be like a random bytes and all those things. In RSA, to develop to generate this pair of keys itself, you will follow like an algorithm using those prime numbers and all those things. And so similar to how we discussed in hash functions, right? So when we say we have a hash function, when we are passing hash of input and we are getting a hash output, what all properties this hash function should guarantee? It should guarantee that even a 1 bit change in the input should change the output, right? And it should be a one-way function, as in I cannot use the output to see what the input is, right? And you cannot guess your output. That should not be that should be very difficult, right? So all these conditions the hashing function should guarantee. Similarly, the public and private key, the public and private key pair, which is generated by the RSA for a particular user, should guarantee some conditions. And what those condition, the key condition is, using your private key, you should not generate your, you cannot, sorry, not this, yeah. Using your public key, no one can generate your private key, right? So this is the key parameter which should hold in this key pair. Okay, so using one key, the other key should not be generated. Especially using the public key, the private key should not be generated. So for example, if this is say 0x80 and this is 0x90, there shouldn't be like an algorithm or something like a efficient algorithm. Using 0x80, I can be able to find out 0x90. So that should not be possible. So how these one-way functions work? In the same way, this condition should also hold whenever we generate a public and private key. So say if Akshay wants to send a message to Ganesh, right? And using this encryption key or something, using the RSA encryption, what they should do is, first of all, each of them should generate a public and private key pair. So say this is public A and private A. So as in Akshay's public and private keys, and this is public G and then private G. Okay, so now Akshay is the sender and Ganesh is the receiver. Okay, the cool thing with RSA is you can use this public and private key in any way you want, and get different guarantees based on which key you are using. So first we look at how do we achieve confidentiality, right? So when we tell confidentiality in terms of the sender and the receiver, right? What should confidentiality guarantee? The confidentiality should guarantee that the sender should be guaranteed that the message whatever the sender is sending should only be read by the receiver. No one else should be able to read this message. So that's the guarantee that confidentiality should provide to the sender, that property confidentiality. So how do we achieve confidentiality using this RSA encryption? So let's see that. So we have message M, right? And we have an um, encryption function. So in RSA there is just like one function, so there won't be like two different functions like encryption and decryption. There is just um, one function only. So basically just say it is RSA transform or something, RSAT, right? So it is just one function, and what it does is uh, for the sender to send it to the receiver, he will use the receiver's public key. So here receiver is Ganesh, so he will use the receiver's public key, and he will pass this public key of Ganesh and the message to this transform function, and it will generate an output. Okay, and this will be the encrypted output. Now this encrypted output he will send it to Ganesh, and Ganesh, on receiving this encrypted output, he will use the same function RSA underscore T, the standard RSA transform function, but here he will pass the encrypted output as the input, and instead of passing the public key or something, he will pass his own private key, priv G, and the output of this will be the actual message EM. So this is how the RSA works for sending a message, and if I want to have confidentiality. Now how do we prove it is indeed confidential? So how is that this encrypted output? Anyone else can just snoop in and read the message, right? How is it protected? We know for a fact that this private component of the RSA pair key for Ganesh is only known to Ganesh. Only known to Ganesh. So this is sort of like a condition, and this based on this condition, we know for a fact that this private part, the private key part, is known only to Ganesh, and no one else knows this private key. So, and the public key everyone knows. So using this, right? Using this assumption, we can easily prove confidentiality. Okay. Now say the same um, sender and receiver, but instead of requiring confidentiality, let's say the sender wants to provide his one second. Let's say the sender wants to provide integrity. The receiver wants to ascertain whether it is whether the data has not been tampered with or not. Okay, so by integrity, what we mean is what guarantee we specify is the sender. It's actually from the sender's perspective. Sorry, the receiver's perspective, right? The we what does integrity guarantee? Integrity guarantees that a receiver is assured that the information came from that particular sender only. So this is the guarantee that the receiver should be assured of when we have to ensure integrity, right? So in that case, what how the message would be passed is, say, same message M and the same transform function, and Akshay is sending to Ganesh. Now Ganesh should be assured that the message is coming from Akshay only and not from anyone else posing as Akshay. So to guarantee this, how will the message be generated, the encrypted messages? They'll use the message input M, and instead of, so in the previous case for confidentiality we use public key of Ganesh, right? Here we would be using the private key of Akshay, and this will generate an encrypted output. And when this output is passed to Ganesh, he will use this output, pass it to the transformation function, the encrypted output, and here he will use the public key of Akshay, and he'll get back the message EM. Okay. Now, how does this way of sending message ensure integrity? So we know the assumption that the private key is known only to that particular user. The user's private key is known only to that user. No one else knows the private key. So here we are using the private key of Akshay to encrypt the message M and get an encrypted output. So this private key is sort of known only to Akshay. So based on this guarantee or this assumption, right, the encrypted output, whatever Ganesh receives, can only be encrypted by Akshay because he is the only one who can encrypt that message because he only knows the private key, his private key. So when Ganesh receives the message from Akshay, and if he um, decrypts it using Akshay's public key, which is known to everyone, which even Ganesh knows, he will get a proper message M. And this will only be possible if that message, the encrypted output, was initially encrypted using the private key of Akshay. Right? If someone else had tampered with the message, then this message M would not have been generated properly. So through this, integrity is supported. So the cool thing with RSA is there is no like a specific function like encryption or decryption. It's just that the transform function would be present, and if you pass a message M, the property of RSA algorithm is if you pass the public key, it will provide, say, encrypted text E1, and if I pass the private key and this E1 to the transformation function, it should give me back the message M. Similarly, the vice versa is also applicable, right? The same transformation function, but if I pass the private key and the message M, it should give me say E2, and if I pass E2 and this public key, then it should give back M. So based on what is being used, public first private or private and then public, the confidentiality or integrity varies, and we can sort of use both in the same encryption, like sequentially we can use both to ensure both integrity as well as confidentiality. So if you look at the guarantee, whatever confidentiality and the integrity requires, right, you can sort of understand which where is the public key being used and where is the private key being used. So just see it from this perspective. For confidentiality, who are you guaranteeing confidentiality? You are guaranteeing the sender the confidentiality, right? So there you are using the public key of the receiver. Whereas in integrity, you are guaranteeing the receiver that the information that they receive is non-tampered, right? So there you are using, at the receiver side, you are using the public key, right? So you can view it as this: the private key is sort of unique to every user, and it sort of identifies that user, that's his um, ownership, right? And the public key acts like a Aadhaar card to the user. So you sort of like think it like this way: you have your Aadhaar ID, you send out your Aadhaar ID is known to everyone, right? Your friends, relatives, you would have submitted your Aadhaar card to any agency or something for verification like that, as a proof of address like that, and everyone knows your Aadhaar ID, so that's sort of your public key. But your phone, the OTP, whatever is sent to your mobile number, that acts like a private key, right? So the guarantee is that the assumption is only you have possession of that particular mobile phone, and whoever controls that mobile phone controls that Aadhaar ID basically. So whoever controls that private key will be controlling the public key paired with this private key. Okay. So any doubt in this thing? So it's sort of like slightly tricky, but just view it in this way: like who is assured of what guarantee? So in integrity, it's a receiver who is assured of, and in confidentiality, it's a sender who wants it to be confidential, basically.
In this case, am I audible?
Uh, just a second,
Hello.
Mahendra. 1 second. So, Samiksha, is your doubt clear?
Yes, thank you so much, sir.
Okay, thank you. Yes, Mahendra.
Yeah, in this
Have any question?
yeah, in this integrity thing, how is the receiver ensuring that like M is the message, because he is not aware of what is M here.
Right. So how does the receiver know whether the message is correct or not? It can decrypt to some message you are
Yeah,
telling, right?
yeah.
Right. So it can be something like right. So what? Okay. So usually, what happens is they don't directly. So usually, this integrity they call it by the term like digital signatures, like that. Right? So how these digital signatures or basically this integrity scheme works in public key systems is they won't be signing on this entire message EM. What they will do is they will generate a hash for this message EM. They'll generate a hash for this message EM, and on this hash they will sign as in they will use this. So instead of directly placing M into the transformation function, they will place h of M, hash of the message M. Okay, and this will be the encrypted output, and they will send the message in plain text also. Okay, and at the receiver side, the receiver will see the message, and what they will do is they will generate the hash of the message h of M, and this encrypted output is basically the encrypted hash, right? Whatever the sender sent, they will decrypt this encrypted output using the public key of the sender. So here public key of Akshay, and get the actual hash of the message whatever was transmitted and compare it with the actual hash that they computed. And if both are equal, it means the message has not been tampered with. If they are different, then it means the message has been tampered with. So instead of directly comparing it with the operating it on the message, they send it on the hash of the message basically. And the advantage is the operation to so basically your encrypted output is, say like you are sending a 1 GB file, then your encrypted output is not 1 GB but it's just 256 bits, right? That hash output. Whereas if you hash the if you want to encrypting this as in integrity for the entire message, if you pass the entire message, it will be time consuming as well as on both sides, right? For encryption and decryption, you should be working on the entire 1 GB file. That's not required. Instead, they sort of add an indirection where they encrypt only the hash of the message in this instead of directly passing M to the RSA transformation function. So in that way, they will be able to easily judge whether the message has been tampered with or not.
So in this case, there are HM is also shared with the receiver, and ENC output, which you're saying encrypted output of the message, is also shared with the receiver. Is that the way it is?
Okay, okay. So let me just redraw this. So uh, Akshay is sending it to Ganesh, right? What will happen is this is message M, and h1 is equal to h of M, right? Now what they'll do is the message what they'll be sending it to the receiver is it will be M, comma RSAT of h1 and then private key of Akshay. So this is the entire message that they will be sending. The message M and then the encrypted content of H1 with respect to the private key of Akshay. Now Ganesh on receiving this message, he will receive the same thing, right? So what he will do is he will receive M and he will calculate H of M and say store it in H2, and he will receive this RSAT, right? This encrypted one. So let us take this as encrypted one, right? So what we'll do is we'll pass this encrypted one RSA transformation and you'll use the public key of Akshay, comma encrypted one, and say this generates in some value like h3. Now, if no one has tampered with, then it should be h2 should be equal to h3. This should be true, right? If as in h3 is equal to h1, basically. If not, then both won't be equal.
No, but in this case, the message itself is being shared unencrypted.
Right.
And
So here, the sender or the receiver, they don't require confidentiality. So say this application where your say weather forecast um, broadcast station, right? So some say in the army or something like general weather forecast station. It should not be the case that the enemy army guys just generate like a fake weather broadcast saying that it's going to rain in half an hour. Everyone please fall back like that. It should not be that case. So they should be able to assert that the weather forecast indeed came from that broadcaster or not. But the information that that is being shared is sort of known to everyone. It's not meant to be confidential,
no,
but
but if, yeah, if it is meant to be that way,
if
then we
it's
can't
okay.
use RSA.
Yeah. So then we should uh, encrypt this message M also. But this message M will be encrypted using the public key of the receiver, this public key of G. And M won't be sent directly, it will be RSAT, this encrypted one will be sent. So if you send both these things without sending the M directly, then it means it's both, yeah, if you just, it's both confidential as well as integrity is achieved.
Yeah, okay.
Right. So usually, if you just want integrity to be achieved, this is the preferred way because the size of the input that has to be encrypted is also very less, and the time to check is also very less. Say if you have a 1 TB file that you are sending, then sorry, then it will be also yeah, if it's a 1 TB file or something, it will be difficult for you to check it. Say if you have like IoT network, right? So you have like these multiple IoT devices, device one, device two, something like this, and say they are all placed somewhere within like a dense forest to calculate sunlight, the penetration factor, and water availability, and acts like a mini CCTV camera to monitor wildlife and all those things. And say they are all connected via internet, they send back a feedback periodically containing all this information to a server, right? And say there is some software bug or something, and now they have to um, patch up the software. So basically, it will be like a remote update. So when you in your laptops, when you use Windows OS or any operating system, you will get these messages, right? Remote updates require software updates, right? So in the same way, these IoT devices will also require software updates periodically, something like that, right? So for better performance, or some bug was found and they want to rectify that bug in the software. So they'll be sending these remote updates to these IoT devices, and the computational power of these IoT devices will be very low, right? So in that case, you just need to ensure that that update is the integrity should be maintained, right? The update can be open. What update is being done, it can be open, it need not be confidential, but the integrity should be maintained for these updates, because it should only be the specific server that should be sending the update and changing that software. It should not be some attacker controlled server sending out a malicious update. So there all if we just use this hash alone, it will be easy for these IoT devices to prove that it indeed received the updates from the server and no one has tampered with those updates. So is this clear, Mahendra?
Yeah, yes, sir. Thank you so much.
Okay, good. Thank you.
I actually had a doubt on there is a assignment two, and there is one question which I feel is not properly framed. So is it
Question two is it?
in assignment two, question two? There is
Uh,
one operation. It says decryption, but I don't see any decryption there in the steps.
right.
I think it's not properly framed. So how do we, whom do we tell that?
Right. So usually, you should send a mail to NPTEL or something because I don't have direct control over the assignment or the evaluations. So the live sessions only I am in control of.
Okay,
So you should send a mail to NPTEL or something like that. They should be able to rectify this, or like if it's a wrong question, then they'll give marks to everyone. If it's like a
okay,
mistake or something.
okay,
Because they are the ones who release the assignments and they have control over that
okay,
platform.
okay, sure.
So anyone else, any other questions you have? Okay. So if you don't have any particular questions or something, you can drop off the call if you want. If you have any questions that you want to discuss or something, you can stay on the call. So I'll be here for like around another 10 minutes or so. If you have any questions, do ask. Hello? Shulti, do you have any query? I guess you unmuted yourself. Shulti, do you have any query? Okay. Uh, Anyone else, any other queries you have? You can take your time like to think and ask. I'll be here. So usually the trend is the first 2 weeks the queries would be sort of related to encryption because those are the things that are being discussed in the lectures. But I'm sure that in week three the number of queries will raise exponentially because that's the part where the actual blockchain contents come into the picture, the Bitcoin and all those things. So that's where things will become interesting actually. So it's yeah. Do you have any queries in the week one's assignment question or something? Hope everyone got good marks in the assignment one, I guess.
The due date is still not over, sir, for that.
Oh, okay. Due date is still not over for us.
No,
Okay.
no.
Okay, I see. Okay. Right. Okay. Yeah. Probably once the due date is over, we can have a look at assignment one. We can discuss that. But I had a look at the questions. It's sort of basic only, as in if you went through the lectures and they are sort of like directly taken from the lectures, the questions. So it should be doable. Um, yeah. Question 2, assignment 2 alone, just mail to NPTEL. I'll also try contacting the course, the TAs, as in the ones who set the questions. I'll try contacting them.
Sure,
Let's
sir.
see. But you just write a mail to NPTEL as early as possible. Because if you write it like late, it might have been,
Okay.
uh, they won't change it usually. So it might
What
be.
exactly is the ID? If you can just help me with that, it'll be really helpful.
Okay, so maybe I can. So I guess you have posted this question on the forum also, right?
No, I have not posted it on the forum actually.
Okay, so just post the question on the forum. I'll
Okay.
reply to it after going through the question.
Sure, sure. Okay. I will do that. I'll post
Okay.
it on the forum. Yeah.
Okay. Avi Ra has asked a question. What is Merkle and Merkle root hash? Can you explain it? Okay. So Merkle tree is nothing but okay. So for example, let's say you have let's say you have eight different files. Okay, so F1, F2, F3, F4, F5, F6, F4, F5, F6, F7, F8. So assume you have eight different files, and all these files should be sort of it should be non you should maintain integrity of all these files. Okay, so one way is you can sort of have a hash for each file, right? You can sort of have a hash for f1, right? So let us keep it like, okay, you make a hash, you pass this input to a hash function, and you get h1, and similarly h2, h3, H4, H5, H6, H7, H8. So you pass the hash functions and you maintain all these hashes together. So that is one way. But the thing is, if it's say like hundreds of files, then you should be maintaining hundreds of hashes, which is sort of not prudent, right? It will be storage consuming also, and that is one. Now that's a disadvantage. Now what's the other way? So what they did is they came up with this concept called hierarchical hashing, and the name given to this thing is basically a Merkle trees, right? So what they do is they form like a tree data structure. So if you have learned programming and data structures, there is there is a particular data structure. So similar to your linked list and stack, right? Similar to this, there is a data structure called tree, and this specifically a tree data structure. This Merkle tree. So what they do is they will they construct a tree of hashes based on all these individual hashes. So say h1 h2 up till h8 are the individual hashes of all these files. Then what they'll do is they'll construct a tree like this. So they'll combine both these hashes together, and they'll take hash of h1 appended with h2, which will be h 1 2, right? That is one. This will be h34, which is hash of h3 combined with h4. uh, this will be h56, hash of h5 and h6 combined, and this will be h78, which will be hash of h7 and h8 combined. And similarly, now just go a level up above and repeat the same step. So this will be h1234, which is hash of h12 concatenated hashing, or what you called it, right? H12 hashed with concatenated with h34, and similarly like this, which is h5678 equal to h56 appended with h78. And now again go a level to the top, and you'll get h1234567. That is just a single hash. It is nothing but hash of h1234 combined with hash of 5678. So basically the hash of the below level becomes the input to the above level hash. The output becomes the input to the above level. So it's constructed in from bottom to top, it's constructed. So this is the way it's constructed. Now the entire thing put together is your Merkle tree. Sorry, this is how like the tree data structure is generated. Now coming to Merkle tree, so what they call the Merkle tree is basically, say what happens is, um, assume you have this 8 files, and the receiver, say this Merkle tree is part of some this all the 8 files. Assume these 8 files are stored in some server, some third party server, or say some torrent server. Okay. And of course you cannot trust this server, because you don't know who's managing the server. You don't know the owner, so the owner is unknown, anonymous owner. So you basically cannot trust this server that it will be sending, say if you want to download file 7, right? It won't be you won't be guaranteed that this file 7 is indeed this is not tampered with, right? So in that case, what do? You rely on the hashes. You rely on the hash values along with these files. So basically you want to ensure that when you calculate the hash of f7, it should be the same as h7, which is stored along with the file 7. But just like that, if I just I can just send back like a new file, say f7 dash, I can send back a new file, and I can generate a new hash for this h dash and send this hash also. So there is no way that the user can be guaranteed that that file has not been tampered with, because even the hash value they can just change it and send it, right, which matches the changed input. So what Merkle tree does is, um, they sort of guarantee the entire files, all the files put together. They guarantee that it has not been tampered with. As in, It's not just F7 or F8 file that it guarantees individually, but all the files together has not been tampered with. That's the guarantee this hierarchical tree hashing provides. So say now as a receiver, say the receiver sends a request to get file F7. Now instead of just sending back F7 and H7, what the server will do is it will send back a portion of the Merkle tree. So basically what it will send back is it will send back a portion of the Merkle tree which is as follows. So what it will send back is, I'll just draw it down. So it will send back the file 7, it will send back F7, and what it will send back along with F7 is it will send back the portion of the filled in Merkle tree which is H8 and then H1234, this one, H1234 and then H56. H1234, H56. Okay, so H8. So this will be the portion of the Merkle tree which it will send, exactly like this it will send. So it will send the file 7 and it will send these values H1234, H56 and H8. Now what the receiver will do is he will calculate the hash of this file and generate H7. Oops, sorry. He will generate the hash of this file and he will calculate H7. Okay, so it's basically the question marks sort of act as fill in the blanks. Okay, so he will uh, he will calculate H7 and H7 and H8 together should be this H78. Okay, and H56 and H78 together should be H5678 and these two together should be H12345678. So what basically the Merkle tree will guarantee is it will give the file F7 and this part of the tree whatever is generated from the previous diagram, right, this part of the tree it will give to the user. Now the user what he will do, what the user will do is the user will generate H7 and fill in the blanks and compare with the tree that he received from the server. And if these values, specifically this value, this value, this value and this value, all these values are equal, it sort of is guaranteed that that file F7 is proper, it's not been tampered with. Okay, so did you understand up till here the subtree and all these things, right? Now you might ask a question, why should they send back the subtree? Why can't they just send back say H7 and let us calculate H7 and see whether this H7 is equal to the one that the server sent. The issue is if I use this technique, it's guaranteed that F7 is only correct, right? It might be the case that this is like the server is containing a huge document over so many terabytes, and each F1, F2, F3, all these 8 files are sort of, they are part of the same file. If you have that assumption, right? So all are put together semantically they become one single file. And it's just that the receiver wants to get the seventh portion of the file alone, say the seventh page of the document. In that case, if I just give this F7 and H7 alone, what is being guaranteed is that seventh page is alone, not tampered with, is guaranteed. But what should be guaranteed is all the 8 pages have not been tampered with. That is one. The first guarantee of this Merkle tree is F7 is not tampered with. And the second guarantee what it provides is F7 is indeed part of F1 to F8, and specifically F7 is placed before F8. So if you notice over here in this diagram, if I sort of I can like rearrange the files also, right? F1 and then F7, F4 like that. So in that case, the ordering of the files also plays a key role in how these hashes are being generated, the ordering of files. So if it's F8 and F7, then the hash will totally be different, right? Even though it's the same. What I mean is hash of H7 concatenated with H8 will not be equal to hash of H8 concatenated with H7. So both will be totally different. So the ordering of these input files is also matters when we are generating the Merkle tree. So basically by this tree data structure, what we achieve is when the receiver wants to be sure that the file whatever is receiving is not being tampered with, and it's also part of this group of files, and it's located at a specific position based on the ordering. So all these things, right, the ordering, and it's part of all the 8 files, and that the 8 files are also have not been tampered with. So all these things put together can be guaranteed by the single Merkle tree instead of just relying on a single H7 hash value. So the Merkle tree, if you notice what the receiver gets back is, he just gets back this H1234. So that is basically, he gets back this node alone in the tree. If you notice, he does not get this node over here or this node, because these two values put together is only this value. So the user gets just this node, and then this, and then H8 and H78. So out of like all the values H1, H2, H3, H4, H5, H6, all these values, he just gets 1, 2, 3, 4, 5, 6. Just a sub tree only, he gets just a part of the tree. And he can use this part of the tree to sort of ascertain that the file 7 is in the correct location what he expected, and it's sort of not tampered with. Now say if I want to receive a file F5, now what would be the Merkle tree that the receiver would be receiving apart from the file F5? So he'll be receiving sort of the similar one, H1234 and the H12345678 like that. But instead of receiving H8 and H56, he would be receiving something like this. So it will be H1234, H12345678, and then H5678, H56, H78, and over here H6. Now basically the things that the receiver should check is, he should fill up this H5 value and fill in this H5 value and see that by concatenating H5 and H6 he gets H56, by concatenating these two he gets this value, and by concatenating H1234 and H5678 he gets this value. If this reconstruction of the values matches with the one that he received, the receiver received, then this H5 is correct and integrity is maintained, as well as the ordering is maintained among the files. So this is the concept of Merkle tree, and why is Merkle trees useful in bitcoins is, for example, so when we talk about Bitcoin, this will become more clear. But just giving a sneak peek, in Bitcoin, it's basically financial matters, right? So you will be say A is sending 5 Bitcoins to B, right? And then say A is sending another 6 Bitcoins to C, and say don't view it as Bitcoin. So why this Merkle trees are important is because it not just maintains the integrity but also the ordering of the data, ordering of the data which it is ensuring integrity. So assume that where is this ordering important? Say for example, you are all part of a bank, and I have say 1,000 rupees, and I'm expecting 2,000 rupees from my friend. And once he sends the 2,000 rupees, I will send 2,500 to. I'll pay the fees, my academic fees 2,500. Now the ordering should be, first I should receive the amount from my friend, and then only I can pay the fee. But say that first the fee transaction is included in my passbook 2,500, and then the transaction that my friend sends it to me, the credit transaction is included in the passbook. So first the debit and then the credit. The issue is when the debit happens, my balance is 1,000, I send 2,500, it goes into negative balance, which is not correct. So the ordering should be first the credit and then the debit, right? So in this case, all say instead of you are having these files, individual files, you can have transactions in those places. So in transactions, a list of transactions you will be having pertaining to your specific bank account, like that. So in that case, the order in which these transactions are placed, right, order in which they occur, order in which they are printed out, it should be proper. It should not result in a negative balance in any way. If it results in a negative balance, then there is some mistake in the way the bank operates, right? It's just like you are giving money out of nowhere. So that's wrong. So in those cases, all it's important that the ordering is also maintained, and Merkle trees sort of help out in maintaining this order as well as integrity. So is this logic clear, Merkle trees? So this is like a practical example of why they came up with hierarchical hashing. Okay, so clear, sir. Is it only binary we take every time to make the Merkle hash, or can we take multiple files on level hash to reach the so it can be up to you. So this file F1 can be like a group of files put together, or it can be just one single file. It can be anything. Okay, so at the receiver side to reach the Merkle root, that's the beauty. You need not require F1 till F7. So if I am receiving uh, okay, if I am receiving F7 from F1 to F6 and then F8, none of these files I need to compute the hash. The Merkle tree, whatever the receiver receives along with the file F7, is sort of like a subtree with all the values filled in, and the receiver should just compute the hash of file 7, and along with that the remaining hashes in order to reach the root of the Merkle. So this is basically your Merkle root. So if the Merkle root is correct, whatever you computed is correct with the one you received, then the ordering and the integrity is maintained. So does this clear your doubt, Avira? Okay, cool. Okay, sure. So everyone clear about how Merkle trees work and why we need Merkle trees? Any queries in this concept? Because this concept is sort of important in Bitcoin. They use this specific type of hashing and um, hashing to in the Bitcoin transactions and everything. Okay, cool. So any other queries you have apart from the Merkle tree, Merkle root? Okay, so if you don't have any queries, then we can end the session if you want, or if you want to discuss anything else, I'm open for discussion. Okay, I guess no one has queries. Okay, then let's end this session. Okay, okay, wait. I have it. Avira, do we need to learn the algorithms of SHA and all for the exam? No, so not in depth. Just have a look at the how can I tell? Have a look at the lecture contents. Up to what level they discuss the mathematical algorithms, the terms. Just have a meaning of those terms alone. So definitely they won't ask you to compute the SHA or the encryption. The how the encryption works, they won't ask you in exams because you cannot do it manually, it will be time consuming. But those small say for example how the message is being padded for the SHA hashing algorithm like that, so they would have asked in the assignment question or something like that. So how the input is padded or some conditions for the hashing function like that. So those alone you just have to take note of and see whether you understood that or properly. Those they might ask the simple mathematical questions in those particular algorithms. So they won't ask the entire algorithm or something like that, just those conditions or something. So for example, this one way function, what it means, one way property, and then this uh, pre-image attack, post-image attack, and all these things. Apart from that, you need not require much things. Is that clear, Abhira? Okay, good. So, any other queries anyone has? Okay, so if no queries, then we can end the session. Okay. Thank you everyone for joining and for making the session interactive. Let's all meet next week Saturday the same time, and I'm sure that session would be much more interesting because you would have started learning Bitcoins by. Yeah. Thanks Avi. Thanks Mahendra. Thanks Divya. Thanks, Sindhuja. Thank you. Yeah. Thank you, Harshita. Thank you, Chirayush. Thank you. Thanks, Mohan. Yeah. Thanks, Samiksha. See you. Okay. Thank you all. I am ending the session now. Thank you. Thanks, Simran. Thank you. Thank you all. I am ending it. Thanks, Neha. Thank you. See you all next week. Thank you.